For the second part of lesson 1, we're actually going to do some measuring of segments and of angles. Last time we sort of laid out some of the key vocabulary terms. We explored points, lines in class a lot with the planes. And so there's a little learning curve there with all the vocabulary and notation. But basically today, our goal is to be able to measure segments sort of algebraically or arithmetically, ascribing the points to a number line on a line segment, or ascribing the angles to a protractor when we're talking about angles, and kind of work in that direction. So there's a couple key pieces of notation that I want to make sure that we hit. The first is, if we're talking about the length of a segment, we can either write out the length of line segment AB, right? The length of, and then capital A, capital B with a little line over the top. Or we can write the distance from point A to point B. That's a lot of writing. Instead, we can just use this little symbol to talk about the length of segment AB, or the distance from point A to point B, or the space between those 2 points. Same with the measure of an angle. We can name the angle. We talk about 4 different ways to name an angle. CBA, angle B, angle ABC, and if there's a number at that vertex, then we can name it that way. But if we're talking about its measure, we'd say the measure, the little m of angle ABC. And when we're talking about its measure, we're talking about a number. Whereas when we're talking about the angle isn't a number, the angle is just an angle, right? And so you are not your size, just like this angle is not its size, the angle is the angle. And sure, the angle has size, but that's not its identity. This is how we name it, but this is how we refer to its measure, all right? I know that there's nuance there and there's particularities, and it's like, well, how strict are you gonna be on that? Well, I don't know. How can you just do it correctly, right? That's kind of the goal there, like name these well. Our first postulate in this lesson is the ruler postulate, which basically says if I've got a line or a number line, I can ascribe those points to the same points that are on a ruler or on a number line. And so it's not too crazy of a concept, but it looks like x is at 3 and y is at 7. So if I wanted to find the distance between those points, I could do some simple subtraction. The distance from x to y, or the length of segment xy, again this notation without the little hat above, is found by taking the difference between their locations on that number line, whether they're positive numbers or negative numbers or whatever. Now the reason why I have these absolute value bars here is because if I took this location 7 minus 3, it would give me positive 4, right? But if I took 3 minus 7, it would give me negative 4. Well, distance will never be negative, so that's why we have absolute value here. Just kind of keep that in mind if that's a helpful idea. When we're talking about segments that have the same length, or angles that have the same measure, we refer to those things as congruent. That's a fancy, really geometry-only word, is kind of where we would generally see this idea. And so this might be a learning curve for you, right? It might take you a couple months to use the right notation in the right time. It's like speaking correctly, right? Sometimes we learn new words, and so if you're 3 or 4 years old, you might speak incorrectly because you're still learning the language. Same here, you're still learning a new language, and so you might use the wrong notation at times. You might say the wrong things, but we'll correct it and we'll learn. And we're not just going to let it slide, we're just going to try to do things well. So there's a little difference between equals versus congruent. Numbers are equal. So 4 equals 4 because the length of this segment is equal to the length of this segment. So we would use the segment length notation when I'm talking about equals, because this is referencing a number, and this number is equal to that number. This length is equal to that length. All right? Just like you can have apples and oranges, those aren't equal to each other, but the number of apples might equal the number of oranges. So that's when we use equals. Congruent, on the other hand, there's this little hash mark that you're going to see marking segments or marking angles as we work through the rest of the school year. All right, so this is not going to go away. So let's try to get it today, and if not, then we'll get it next time. And if not, we'll get it the next time. If not, we'll get it the next time. But these segments are congruent. I might not know what their length is. All right, so I'm going to say that those segments are congruent, and I'll use that congruent symbol. It's an equal sign with a little tilde above the equals. All right, so the segments are congruent, but the segments' lengths are equal. I know it seems like not a big deal, and it shouldn't be, so just do it well. If it's not, then I'll mark it accordingly. So here's a way in which we can compare lengths. Here I've got a number line, and I've got points on the number line, like they would be points on a line, and then I've got segment here, I've got a segment there, I've got a segment here, I've got this segment there, I've got this whole segment. And so we want to find the length of segment AC. What is the length? What is the distance from A to C? Or what is the length of that segment AC? Well, to find that length, what I'm going to do is I'm going to take the location of A and the location of C, and I'm going to subtract them. All right, just like I wrote a couple slides ago. So the absolute value of -8 minus -2 is going to equal the absolute value of -6, which is 6. So the length of AC is 6. Now if I did -2 minus -8, it would give me +6, and I'd take the absolute value. So the absolute value there is not relevant. The length of segment CE, I'll do this one a little bit backwards. I'll take the location of E minus the location of C, and I will do that subtraction. So there's C, here's E. I'm going to say the absolute value of 2 minus C is at -2. And so 2 minus -2 is 4. And the absolute value of 4 is 4. So the length of that segment is 4. Are these segments the same length? No. 6 does not equal 4. So the length of AC does not equal the length of CE. Therefore, that symbol means therefore that's 3 dots in the shape of a triangle. Segment AC is not congruent to segment CE. All right, so that's our answer, but this is why that's our answer. Sometimes we just want to write the answer, we don't want to explain why. You wouldn't want me to just tell you the answer, those are not congruent. You want for me to explain why they're not congruent, and you want me to explain the notation I'm using, and I want the same from you because I want you to articulate to me that you understand the concepts. All right, this one right here, I would like for you to do. This might take you some time to do your subtraction, but you get to do this. Pause the video because I'm going to move on, but you are going to do example 2. So find the location of those points, do your subtraction, tell me are those segments congruent, yes or no, and explain along the way why they are or are not congruent. Explain why the length is what you're saying the length is. Do the work, show the work, and then you get full credit. Now again, there might be stress on this. You get full credit if you try to do it. If it's wrong, okay, we'll correct it in class. All right? But if you don't do it, then yeah, you lose those points. All right, so please do this. Postulate 2 is what we call the segment addition postulate. And basically what that says is that if I've got points A and C with B in between, it doesn't have to be right in the middle, but in between, then this part plus that part adds up to the whole thing. All right? Does that make sense? Like if I had a stick and it was this long and I measured this part and then I measured that part, well, the whole stick would be this part plus that part. So it's not necessarily a confusing concept. The key here for your success is to make sure that you use a model. You have to make a drawing. If you're not making a drawing, then it's going to be hard to visualize it. Write all the steps, including this step. The length of AB plus the length of BC equals the length of AC. This is an important step, and it might not seem like one. You might want to start just, oh, I want to do the algebra. Great. We'll write the geometric equation first, and then the algebraic equation. I promise you, if you follow those directions, you will be a lot more successful this semester. Then you get to enjoy some algebra. Sometimes people are like, why don't we do algebra 1 and then algebra 2? Well, we're going to do applied algebra this whole year. Like, we're doing a lot of algebra 1. So I hope that you enjoy it whenever we get to do it. So let's go ahead and show a situation where we would model this piece of information. Because we've got A, we've got B, and we've got C. All right? And the length of AB is 25. The length of BC is 2x. And then the whole thing is 4x minus 5. So your step 1 is to draw the model. You have to do that. If you're given this information and you don't have the picture drawn, it's going to be hard for you to create your equation. So drawing the model is part of the deal. We'll do that in class, and I'll ask you to do that on an exam too, where you get to draw the picture. Now, I'm going to write the geometric equation that those two parts add up to the total. That the length of AB and the length of BC add up to the total length of segment AC. And so now I've got an equation that I can solve for x. This now looks like Algebra 1, Chapter 2. All right? Fancy pants stuff. I can add 5 to both sides. I can subtract 2 x's from both sides. And I can divide by 2 on both sides to solve that equation. My expectation is that if you have an algebraic equation, you can solve it. The goal is that what we're learning here is you have to create the equation. So this is the hard part. This is supposed to be the easy part. Now, if you struggle with that, you need to see me. All right? So we have drawn a model, we solved for x, now we can find the lengths of the segments. I don't really want to spend time doing that, but the length of BC is 2 times x, which is 2 times 15, which is 30, which is the length of segment BC. All right? And so you can obviously do that work, and you don't need me to do that, but you can go ahead and find the length of AC. Midpoint. This idea of a midpoint is if the point B is in the middle of points A and C on the segment. If it's in the middle, we're going to call that a midpoint. We say that that midpoint bisects the segment. That's a fancy word that just means it gets cut into congruent parts. or, so congruent parts, or equal halves. All right, we like equations, so we're going to like to say equal halves, and we're going to like to set those parts equal to each other. That will be our equation, not a this plus that equals the total, but a this is equal to that, right? This half is equal to that half. So here we've got T being the midpoint of VA. So here's V, here's A, and right smack in the middle is T. I'm going to put that hash mark there that shows that those segments are congruent. This drawing means that T is the midpoint of VA. That's what that picture means. Now I'm going to label it with all of the awesomeness. I've got the length of VT is 4x plus 3. I've got the length of TA is 6x minus 11. And yes, this plus this does make the whole, but I don't have a length for the whole thing. So I can't make that equation. Instead, my equation is, well, T is the midpoint. So this is congruent to that. If VT is congruent to TA, then that means that the length of VT is equal to the length of TA. That's what congruent means. So I can write the equation that 4x plus 3 is equal to 6x minus 11. I can add 11 on both sides. I can subtract 4x's on both sides. And I can solve for x by dividing by 2 on both sides. Once we can draw the model, we can solve for the variable, we can plug in the values to find out that the length of VT is equal to 4 times x plus 3, and I can do, that work and that thinking to find out what the lengths of these segments actually are. All right, I'd love for you to finish that if you could for me, please. The key here is to be able to create the drawing based on what you are told. You are told this information, you are given that information, create the equations and work from there. All right, angles. Let's name these angles. I'm not going to write this down. I'm just going to do it. I can call this angle, angle 2. I can call it angle L. I can call it angle FLP. I can call it angle PLF. Write all those down. When we're writing an angle, it's not a less than sign, and it's not an L. This is angle L. I'm having you do this on purpose because I don't want you to write your angle sign like an L. I also don't want you to write your angle sign like a less than sign. If you write less than 2, that doesn't make any sense. All right, so write these two and then write the other two names that I spoke out loud. Hopefully you're listening to the instruction and not just writing the things down. You have to be able to hear the things so that you can do the things. All right, if you are trying to do a lesson without listening to the instruction, you're only getting a small percentage of the actual content, and you're robbing yourself of a full understanding of the material. All right, this is not new information. You know acute, right, and obtuse. What you might not know here is a straight angle, so make sure that you have this diagram down as well. Pause if you need to. But a straight angle is one that the measure of the angle is 180 degrees. All right, you know acute, right, and obtuse. That's not new stuff. That's elementary. But right here, this might be new. You might not know that information, so I want to make sure that we're clear on that. Like we can have congruent segments, we can also have congruent angles. If their measures are equal, then the angles are congruent. You'll see that we have the hash mark. We draw the arc, and then we put a little hash mark in there to show that those angles are marked congruent. Again, that difference in notation is one that we will get better at understanding as time goes on. Be patient with yourself. It's new stuff, right? So be patient with yourself. Just because I say it once doesn't mean that you get it the first time, right? It might take you a couple months to get it. Hopefully you get it by the end of the lesson on next time that we're together. This is a little bit hard to kind of draw and manage, but basically what we're saying is that every angle can be applied to a protractor. And we can use that protractor to measure it in degrees. We're familiar with measuring angles with degrees. There's other units of measures for angles, and we'll deal with that in pre-calculus or maybe college algebra. But for here, we're just going to use degrees, all right? So the measure of the angle is, like this angle right here is 60 degrees if we know how to use a protractor. The measure of this angle here is 120 degrees. And together, those angles measures, 60 plus 120, adds up to 180 degrees, the whole straight angle. All right, so that's where those parts and pieces, we've got an acute angle here, we've got an obtuse angle there. Together, this acute and obtuse happen to make a straight angle. Sometimes an acute and an acute makes an obtuse angle. Sometimes an acute and obtuse makes another obtuse angle. Here, an acute and an obtuse make a straight angle. All right, so if you're given a straight angle, you know its measure. If you're given a right angle, you know its measure without them saying that the measure of the angle is 90 or 180 or whatever. All right, otherwise they might have to tell us the angle. All right. Probably don't need this, but basically what we're doing here is I can find, if I know how this is marked and I know how that is marked and I know how this is marked, I can figure out the measure of this angle and the measure of this angle by doing some subtraction, right? That part minus that part is going to give me what's left. And this whole thing, subtracting that piece right there is going to give me what's left over here. So we can use that protractor postulate to help us do what's called angle addition. So this is really the key. Those last two slides, if you have something written down for that, is probably going to be sufficient. The key here, though, is that you have this slide down. So make sure that all of this information is down to the best of your ability. So when we're doing segment addition postulate, we're adding the two parts to get the total. When we're doing angle addition postulate, it's the same thing. We're doing part 1 and part 2, and together those make the total. All right? And so the measure of angle AOB, that's part 1, that's this right here, the measure of angle AOB, plus the measure of angle BOC, gives us the measure of the whole thing from ray OA to ray OC. All right, the measure of angle AOC. Notice how these have the little M's in there. When we write these sentences, I can't add angles, but I can add their measures. Just like I can't add apples with oranges, I can add the number of apples to the number of oranges, right? That's how that works. I'm not going to make like a super fruit. I'm not going to make like a super angle here. We're adding their measures. If the angle is a straight angle, we know that AOC's measure is 180, so we can either skip writing that, or we can just know that it's going to be 180 when we end up doing our work. So, in this situation, so here's the example. We're going to show that these measures here and here add up to this measure there. They give us a number, they give us expression, they give us expression. So this part plus that part makes the whole thing. The measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. All right, it's a lot of writing, folks, but it's writing that we can do, and so the expectation is that you do it. So we have 3x and 17, and we have 9x minus 18, and that makes 143. Now we get to do algebra 1. All right, chapter 2. So it's not even like hard algebra 1, right? It's just but maybe it is hard for you. If it's hard for you, then we got to talk and make sure that we're in the right class. But that makes 12x minus 1 is equal to 143. I add 1 on both sides. I divide by 12 on both sides to find out that x equals 12. Now from there, I can go back and I can plug that in to find out the measures of those angles, to make sure what their parts are so that they can both add up to 143. I'm not asking you to do that here. It's just to solve for x. Can you create the equation? Can you substitute the values? Can you combine like terms? Can you add 1 to both sides and divide by 12 on both sides? Can you do that algebra 1 process? Self-reflect on that. All right? If we have a straight angle, then we know what the measure of that straight angle is. So if I have COD, then I know that if I have, COE is a straight angle. If I have COD as the first angle and then DOE as the second angle, I know that those two angles are going to not add up to some random thing, but they're going to add up to 180 because they need to make a straight angle. See if you can do this one. Do this. You've got the picture. Write the equation. The measure of angle COD plus the measure of angle DOE is equal to the measure of angle COE. 10x plus 10 plus 5x plus 5 equals 180. Solve your equation. Go ahead and do that and solve for x. The last thing that we'll do, we talked about a midpoint bisecting a segment. I know this is getting a little long. We are going to talk about a ray bisecting an angle. All right. If you bisect an angle, it's going to cut that angle into congruent parts, which means that the first angle, the first part of the big angle, is going to equal the measure of the second part of the big angle. All right. So if an angle is bisected, then that means that you have two parts that are congruent or equal in measure. They might still add up to a whole thing. For example, you might have a right angle that's bisected, or you might have a straight angle that's bisected. And so you know that each part is 45 and 45, or 90 and 90, depending on the situation. All right. But you'll know that the two parts are congruent to each other, and that's huge. All right. That's why drawing the diagram and marking your picture that you draw is really, really, really helpful. If a segment's bisected, then you know that the two parts are congruent. You set the two parts equal to each other, and you can go off in that direction. I probably won't have you work through this. I might just do this one in class. But if we know that OB bisects angle AOC, then I can find the value of x without knowing what the full angle AOC adds up to. All right? If I can solve for x, then I can know what the measure of this angle is and that angle, and therefore what the total is. And so we'll kind of we'll deal with that at the start of the class. If you want to do this, you can. If you want to just pause and save it, you can go ahead and upload what you've got. But the goal here is that you can actually find the measures of segments, the measures of angles. You can do segment addition, you can do angle addition, and you can understand how to use and apply the definition of bisect.